So welcome to the very last lecture. This is it, the last one. And Leanne, it's your
Okay, so you know that the problems that ask you to solve for the sample size, like find the sample size,
problems that ask you to solve. Yes, okay, I'm
which
aware
is
of that.
n
Yeah.
equals, I have trouble doing that. So,
You have trouble doing that.
or like using the right formula or something.
Okay, well, there's only two that we have for the sample size. One of them is for a proportion situation. And one of them is for a mean situation. Okay, what's the formula in general for the margin of error in the case of a proportion? Right, we have p hat plus or minus what? What's the formula in the case of a proportion? P hat plus or minus what?
And it like z star times the standard deviation over,
What proportion?
so
Proportion. What's the formula there? Z star plus square root of
this,
p hat 1 minus
oh,
p
1
hat
minus p hat
over
times,
n.
oh, yeah, okay.
Now, in the case where we have no knowledge in advance of what P might be, we'll just take P to be, or P hat to be 0.5. And therefore 1 minus P hat is 0.5. And then we plug everything in and solve for N. Or first solve for N and then plug everything in if you're going to use the formula. In the case, if we do have knowledge of what P might be from a previous experiment or a previous study, then we just use that. So if they say, last year's study showed that P is 0.43, then I'll say, oh, okay, well, then I'll just use 0.43. In the case of the mean, we have Z star or T star plus or minus sigma, Z star sigma over the square root of N. In that case, that's your margin of error. You just solve for N. Right? So you can either have the formulas memorized in advance and written down, N equals this, or you can take the margin of error from your formulas and just on the spot algebraically solve for N, and you get the same eventual results. Right? Make sense?
Yes, thank you.
Okay. Yes, no, maybe so. Anyone else? This is the time. This is the time of the season. Anyways.
I had a question on the inference about like the proportion.
Okay.
So I think I kind of got confused because on the homework and when I was reading the textbook, it said that for the number of successes, the number of failures has to be greater than or equal to 10. For the hypothesis test, or like when you're doing like the z-test, but then for the large sample, it's 15, right?
Which one are you talking about right now? For which one?
The just about one population proportion for the hypothesis test.
Wait, for a proportion or for a mean? Because those are two different scenarios. And I just kind of heard you say both in the same question. So is it a hypothesis for a mean or for proportion? So for proportion, we want 10 successes and 10 failures. For the large sample, right? We want 10 successes and we want 10 failures. Correct?
Yeah.
So what was your question exactly? I'm sorry.
And then for the large sample, like for the confidence interval,
yeah,
it's different. Would it be number of successes and failures? Would that be at least 15?
For the confidence, I'm sorry. So are we talking about a hypothesis test now or a confidence interval? I'm still a little confused.
Confidence interval. It's because I like for on the homework, like it's okay. I think never mind. Okay, I don't think I'm making sense, but
No,
for
I'm just trying to understand what you're asking. You could be making total sense. I'm just not understanding it.
so to use the large sample confidence interval, the
Okay,
number of successes and failures has to be at least 15, not 10.
to use the large sample confidence interval, the number of successes and failures has to be at least 50, has to be at least 10. The 15 that you're talking about is to use the t-test for the mean. That's, because we need robustness. We have to make sure that that it's normal, or it's going to be approximately normal. Yes, no, maybe so. Am I making sense?
Okay, yeah, that makes sense.
Yes, everyone?
Do you think that we could do like example problems where we see you do it?
If you have a specific problem, I am more than happy to do it.
I don't have
Do you
one.
do you have a specific problem?
No, I could go find one.
Let's go find one. Let's do it. What about some on the study guide? That's a great place to look. Let's load up the study guide. So files, final study guide. Okay, I have the study guide right in front of me. Why don't you go ahead and pick one?
Okay, I found one.
Okay, I'm going to share my screen. Which one?
Hold on, I have it on mine. Let me go back. I gotta find the number that I just had. Number 4. Problems requiring written solution.
Number 4. What
Where it has the,
what page is it? Can you see what page it's on?
13.
13. Hold on. Okay, 13. That was 10, 11, 12. Okay, so which number 4?
Yeah, where it says a company wants, yeah, that one.
Okay, now would you like to try to do this on your own first, or go right into my answer?
I want to go right into how you do it, because off the top of my head, I can't think about how to go about doing that one.
Okay, so a company wants to know what proportion of its customers will purchase a premium grade of their product based on a new advertisement promoting the upgrade. Fine. They run a pilot study in which they select 100. Oh, I'm going to stop. N equals 100. They just gave me some information. N equals 100. And find that 7 of them purchased an upgrade. So X is equal to 7. Number of successes is 7. Based on the results of this pilot study, how large a sample will they need if they wish to estimate the proportion of all its customers that will purchase the upgrade product to within a margin of error of plus or minus 2%. So the margin of error, ME, equals 0.02 with a confidence of 95%. So we know the margin of error is equal to Z star square roots P hats 1 minus P hats over N. Correct? Well, the margin of error is 0.02. What is my Z star for 95% confidence?
Is it 1.96?
Someone said 1.96. We've been using that all semester, right? Z star 1.96. The square root of P hat, well, 7 out of 100, my P hat is 0.07 times my 1 minus P hat of 0.93 over N. So then I
What,
take, yeah, go ahead.
what is your p hat again?
7/100.
All right.
So 0.07, right? So what do you get for n? I know what I get for n. What do you get for n?
I got 0.0458.
How much you get
0.0458.
for your sample size?
Oh, wait, sorry, I didn't multiply by the 1.96. Yeah. Okay, give me a second.
No problem. I mean, I have it here. So if anyone feels they have it, put it in the chat. Anyone?
How did you write out your equation when you rearranged it to solve for n?
Well, I have 0.02 equals 1.96 square root 0.07.93 over n, correct?
Yeah,
That's your original formula, right?
yeah.
So I first divided both sides by 1.96. Then I squared both sides. Yeah, Jason, I get the same thing. So I have something equals something over n, right? So how do you solve something equals something over n to get n by itself? More specifically, if I a equals b over n, how do I solve that for n?
You times n on both sides.
Okay, so now I have a n equals b. And then
Then you divide by a.
I divide by a.
Okay.
N equals b over a. So someone direct messaged me the answer that I agree with. So what is your answer? Anyone? I'm trying to find, yeah, I can show it to you. I just can't share the screen and do it at the same time. So let me unshare the screen so you can see my work. Stop share. And then I will chart my. Only the host can share multiple. Although I'm not sure that my wording will really have much there. All I have is just this. So I didn't really show my work. I just kind of did it on the calculator. I did I did 0.02 over 1.96 equals a square root of 0.07.93 over n. I then squared both sides. That gets rid of the square roots. And then I just did n equals 0.07.93, 1.96 squared over 0.02 squared. That actually gave me 625.2, which went up to 626. Yes, no, maybe so. Yes, no, maybe so. So did that make sense?
Yes, thank you. I think I'm just gonna need to practice it a lot more.
That should be the same way for every problem, right? Right? The more you practice, the better you get. Are any of you going to attend my little review sessions or any of the other ones? Maybe you're like, well, this Berkowitz guy, I can't teach for shit. So you know what? Let me try one of the other guys. Bajikov or whoever the other guys' names are.
Are they, when is the next one?
Let's take a look. I'm gonna stop sharing for a second. Load up.
Is it on the math tutoring thing that's on Canvas?
It might be, I don't know. I'll put them up here now just in case. Final review sessions. Here it is. Let me share my screen again. And you can write them down again. And there they are.
Thank you.
No problem. So I will be doing on Wednesday, Thursday, and Friday, different times. To be honest, I don't even know who the other professors are. I mean, I've talked to some of them before, but I don't know their teaching styles and how they're going to do it. But I would say the more practice you can get, the merrier, and maybe seeing someone else's perspective, maybe he or she will say something that is illuminating in ways that, you know, I didn't, and everything clicks. You never know. I am free to attend 2 of the Zoom meetings. So that's great. I would encourage everyone to attend as many of them as they can. The more you attend, the better. So, anything else you guys would like to talk about or clear up confusion, et cetera, et cetera, et cetera? If we go to the review meetings, can I make a friend? I'm afraid not. This is for your benefit, not mine. The more you do, the better it is for you. This is your time, anything.
Can I just keep picking problems?
Yeah. No one else is. You go for it, girl. Let's take a look. Where is it? You pick a problem.
Number one, like that was right next to number four.
This one right here.
Yeah. I'm just picking them at random.
Okay. A telemarketing firm in LA uses a device that dials residential telephone numbers in the city at random. Of the first 100 numbers dialed, 23 are unlisted. This is not surprising because 38% of all LA residential phone numbers are unlisted. Identify whether each underlying bold-faced number is a statistic or a parameter. Well, let's take a vote, shall we?
In the chat, you mean? Like
Yeah.
put it in the chat?
Yeah, so what I want to chat is as follows. One of them, either parameter or statistic, comma, the other one, either parameter or statistic. And I'll give you 30 seconds.
So just the two words with the comma between.
Just the two words. All right, so 3, 2, 1, go. Statistic parameters, it is a parameter, it is a parameter. Looks like everyone got that one. Those are answered. That's correct, because the first number comes from the sample. The second number comes from the population. Statistics come from samples. Agreed? Next.
I'm gonna look for some off of like the past homeworks that I've done bad on, so maybe
Okay.
someone else can go while I find one.
I had a question on chapter 22
Okay,
on the homework.
okay.
It was
I'm gonna load
number,
up the achieve, you mean?
oh yeah,
Or you know what, you want to share your screen if possible?
yeah, I could share.
Okay.
Mm. Can you see my screen?
Yep. Mhm.
Okay, so I guess where I was confused was here because it said, so we expect or hear the 20 successes and failures, which are both at least 10. So the
Okay.
conditions for the large sample Z test are satisfied.
Yeah,
And then it asked if we could do the large sample confidence interval, and you would think yes, because they're both at least 10, but
Yeah.
then it says no because they're less than 15. The failures there's 13, which is less than, I don't know if you can see right here. That's why I got confused.
yeah, that's interesting because I felt it was always 10.
So that's why I thought like maybe for like when you do like a hypothesis test, it is 10, but when you do a confidence interval, it has to be like at least 15. That's why I got confused.
Yeah, that's hmm. Yeah, I don't really remember that as being one of the conditions in the book. I'll say this. I know I never really focused so much on those types of requirements.
Mhm.
So if there happens to be one of the tests like that, I'll let you know between you and me. I'm gonna
Okay, so it's the failures and successes, it's at least 10, right? Not 15.
yeah, for proportions, it's certainly 10.
Mhm.
I just don't remember. I don't remember one that's and I just remember this. I mean, it's one of those arbitrary cutoff points.
Right. Thank you.
You're welcome. Yeah, I don't. I've always been more of a fan of like just knowing the proper approach for a problem. And yes, I'm not saying the requirements for when you're allowed to do it, it's not important. I'm sure, of course it is. But it's one of those things that if you actually are in a situation in real life where you're doing it, you know, you'll make sure at the time that everything's okay. You'll have tests way beyond the level of this course to do it. I really wanted to teach and explain just the approaches and what to do versus those types of situations. So if you do come across them, again, it won't be held against you. Okay. I mean, they might be, I don't know. I mean, the problems will be like, probably like the test. First of all, they're all multiple choice. Right? You guys know that, right? Every question is multiple choice. Now, that doesn't mean that they're not going to require work to figure out the answer. It's not all conceptual. You still have to do some work. How many could that? I don't know. I don't have access to the test. So I can't say how many questions there are going to be. And Luis, I don't know how long it's going to take to do them. Yeah, go ahead, Hannah.
I'm looking at the Math 140 Science Study Guide, and I had one question that I kind of forgot to do. It's probably really simple on how to do it, but it's like one of our earlier chapters.
Okay.
And I don't know how to start it. It's the first review packet.
You want to
number-
share it? You want to share?
Yeah, I'll share it.
Okay.
Can everyone see it?
Yes.
It's number 85. Simple linear regression problems.
Okay. In a simple linear regression problem, the following has been computed. What is the slope of the least squares line? So there's a formula for this. But these quantities are not directly the ones in the formula. If you recall what it was, so do me a favor, do you have, hold on a second. I'm gonna load up the, just keep that on the screen for a second. I'm gonna load up the files that I just put, which is the tables and formulas. And okay, so I'm going to share my screen for a split second. So can you unshare for just a second, and then I'll so I can share. Okay, so in the tables right here, you have this right here. Okay, this is the formula for the correlation. R equals 1 over n minus 1, summation of xi minus x bar. I'm going to write this down. R equals 1 over n minus 1, summation of xi minus x bar over sx, yi minus y bar over sy. And it says right beneath that the slope of the least square regression line is r sy over sx. Agree? We all have the same thing that I have there?
Yes.
Everyone? Okay, so go ahead now and share again, please. So can we use the information provided to calculate B, the slope? And the answer is yes. To calculate B, the slope, we need R, we need SY, and we need SX. So I'm going to give you a couple seconds to think about this because this is like a test question based upon the formulas that you have. How can I go ahead and use what they gave me and manipulate them to calculate the slope of the least squares line? I'm going to give you a couple seconds in this one. Would it be just one since E of X equals 10 and E of Y equals 10? Why do you say E of X is 10 and E of Y is 10? I'm curious. Luis? Well, it would be, it's a slope, it is rise over run, but we don't have the rise and the run. We have these quantities that have been summed for us. The question is, can we somehow get from there to the slope based upon those two formulas that we had on the study guide? It's not, I mean, it might end up being one. I'm not promising it's not one. But we got to do the math. So let's see what we can do here. First, what's SY equal to? Yeah, I'm wondering if you guys really have enough information to do this one. I mean, you do, but this is not straightforward. I would not worry about this one. I would not worry about this one. This one is, this one's sufficiently more complicated that I wouldn't worry about it.
Okay.
I mean, I just started writing it out, and even I'm like taking like 7 or 8 lines of work. And I'm like, okay, that's just more complicated than you have to worry about.
Mhm.
So my guess is that study guide is not just from this course, but also possibly for some more advanced courses, and he kind of just threw a bunch of stuff together to create it, because that is something that I covered when I taught 341, which is the more 340, which is the more advanced statistics course. That's not something that you guys should worry about here. So ignore that one.
Okay. Because I was looking at my notes from like, I think it's chapter
Yeah.
5, where we did regression. It was mostly like calculator work, and there was like one equation we used. So
Yeah, I wouldn't worry about it. Yeah. Yeah, just skip that part. I mean, we did, we calculated problems involving the slope when you know R, when you know SX, when you know SY, X bar, Y bar. You can get that from the information that they gave you. But, and I can write it out. If you want me to do it, I can do it. I just think that that is really more complicated than is going to be on the test. Like X bar, for example. What is the formula for X bar? Can you share your screen again for a second? Just to take you in the right direction. What's the formula for X bar? It's the sum of the X's over N, correct? You sum your data points over the number of observations, correct?
Yeah.
Okay, well, they gave me the sum of my data points. It's 10. And they gave me N, it's 4. So X bar is 2.5. Right?
Yeah.
Okay, meanwhile, what's Y bar? Y bar is the sum of the Y values over N, which is again 2.5. So both X bar and Y bar are 2.5. But really, to calculate the slope, we need more than that. We need SX and SY and R. So how do I find SX? How do I find the standard deviation? Well, this becomes a more complicated problem. And you can do it from the information provided, but it's not so obvious. And because of that, I really don't think it'll be asked. I really don't. Yeah, I would not worry about it. Focus on confidence intervals, all the confidence intervals that we did, all the hypothesis testing that we did. I mean, the earlier chapters will still be represented. Know your basic probability rules, know your visual displays of information, know your, your stem plots and your histograms and your calculating the means and the medians and the five number summaries and the box plots. But what is the main part of the class? The main part of the class has been confidence intervals and hypothesis testing. And that's going to be like a big chunk of the final exam. Know conceptually what a confidence interval is and how to compute one. Know conceptually what a hypothesis test is and how to perform one. That's the big stuff. Know how to do those stuff. Least squares, conceptual. Know what a scatter plot is, know what a correlation is, know what R squared is and what it means. But some of those more complicated ones, again, would not worry at all. Okay. Yeah, Mariah.
I wanted to go over one of the previous homework problems. I think I have a hard time understanding the small intervals. So can I share my screen?
Yeah, go ahead. I want to know which of two manufacturing methods will be better. I create 10 prototypes in the first and seconds and 10 for the second. There were 3 defectives in the first batch, which means my p hat for the first batch is 3 or 3 out of 10 and 5 out of 10 for the second. However, this is a very small sample size, correct?
Yes, that's what I have a hard time with.
Well, are there at least 10 successes and failures in each set, or at least 5 in each sample?
Oh, yes. Wait, so it's not a small sample?
It is, because there's only 3 defectives in the first sample. Right? So we're not going to use p hat, we're going to use p twiddle for this instead.
Okay.
Right? Now, once you have that, let's go ahead and do it. So what is p1 twiddle?
10? Oh, wait, no. 3.
No. There were 3 defectives in a sample of 10. How do I calculate P twiddle from that? P twiddle?
Oh.
P twiddle, Twiddle, P twiddle. Although I like tittle more, it sounds funnier. It's both the number of successes and failures in both samples must be greater than or equal to 5. In this case, we only have 3. So we take the number of successes, which is 3, and we add 1. And we take the number of trials in samples in that trial and we add 2. So P1 twiddle should be 4/12. It's the number of successes plus 1 over the sample size plus 2. And what is,
Professor,
yeah,
then in my notes, I have P twiddle equals X plus 2 over N plus 4. Is that for something?
wait, P twiddle, that's for 1 sample. This is 2 samples.
Oh,
You're looking at P twiddle, which is a 1 sample proportion. This is a 2 sample proportion.
but we're still using P twiddle?
Well, yes, but it's the other formula. It's P twiddle versus P1 and P2 twiddle are different.
Oh, right, okay.
When you only have 1, you add 2 to the top and 4 to the bottom. When you have 2 samples, you add 1 to the top and 2 to the bottom for each.
Okay.
Okay, so what is P2 twiddle?
Uh, 4/12.
6/12.
6/12.
Well, there's 5 successes. You add 1, that makes 6. Right? The first batch had 3 defectives, but the second batch had 5. So the first here, let me take a picture of this. Hold on. That way I don't lose it. Okay, let me share my screen. Go ahead and unshare, thank you. So we have P1 twiddle minus P2 twiddle plus or minus Z star square roots of what? Who recalls what it was?
P twiddle times 1 minus P twiddle over N1
Plus 2.
plus 2. And then add that to P2 twiddle, the same thing, but with P2 and N2.
Right. Okay, so 4/12 times 1 minus that over 12. And then 6/12 times 1 minus that over 12. And then I add those 2 numbers together. And then I take the square root of that. And this is a 95%. So what do I multiply by?
1.96.
1.96. So I get negative 0.555 to positive 0.222, and the book or the program has this as a possible answer, so we'll take that.
What was the other situation where you add 2 and 3 and not 1 and 2?
Well, there was one that you had 2 and 4. Is that what you
Oh,
mean?
2 and 4, that's what I meant.
That's the same small sample, but that's for only one proportion by itself, not comparing two different proportions.
Oh, okay, thank you.
Where did you go to do your shortcut to do the plus or minus? Because remember you were like, oh, there's a shortcut to do the plus or minus when you're calculating it. Like once you
Oh.
have,
Oh, I mean, I guess in theory I could use I didn't even think, I just did it by hand. But yeah, I go to stat tests. I would do the 2 proportion Z tests. No, this is an interval. The 2 proportion Z interval. 4, 12, 6, 12, 95%. And it gives me exactly the same result. And a lot faster than doing it by hand.
The calculator works for the small and the large sample sizes?
Yeah, all you gotta do is change the numbers for the small. You don't put in 3 successes and 10 as your n, you put in 4 and 12. You
Oh,
adjust it based upon your new values, and then you put those in, and yeah, your calculator does all the work.
Professor,
Yeah,
Louis put in the chat, I just want to verify one last time. I know you said it a whole bunch, but twiddle is for when it's less than 10 or less than 5.
if it's one sample, then you have to have 10 successes and 10 failures. In your one sample. If it's 2 samples, then each one has to have greater than or less, each number of successes and failures should be greater than or equal to 5 for a total of 10.
Oh, okay, got it.
I have another question from chapter 25 homework.
Okay. I will stop sharing so you can show it. Go ahead.
Can you see it?
Yep.
I thought the degrees of freedom was these boxes,
No,
which would make it 6.
rows -1 times columns -1. So I have 3 rows and 2 columns. So 3 - 1 times 2 - 1, there's 2 degrees of freedom.
Thank you.
You're welcome. That was easy.
Professor, I have a question.
Yeah,
Let's see, I have it open. From chapter, I think it was 3. Anyway, I'll just share my screen, but nobody look at my score, okay?
nobody look at her score. Nobody look at her score.
Okay.
Oh my God, geez, what a low score.
Stop.
I'm sorry, I'm kidding. Okay.
This question that I have open right now, it's a long one, but obviously I didn't get it, so.
Emissions of sulfur dioxide by industry set of chemical changes in the atmosphere. Oh, okay, okay. This is just chemistry. Okay, fine. So a sample of n equals 105, n equals 105, has a mean mu or x bar, I guess, better yet, not mu, x bar, my sample average is 5.43 with a standard deviation of 0.54. And a 5-number summary of all of that. That's the lowest, first quartile, median, third quartile, and the maximum. Does it appear the distribution is quite symmetric, or why? Okay, so you answered that. We can skip it. Or you're not sure about that one.
No, I got that one.
Okay. If the distribution is really that, what proportion of observations be less than 5.05? Well, go to your calculator, second normal CDF. Negative infinity to 5.05 with a mean of 5.43 and a sigma of 0.54. It gives me 0.24, 24.1%. 4 decibels it wants, 0.2408.
Which one did you go to? What CDF?
Normal CDF,
Okay.
and I did negative infinity to 5.05 with a mean of 5.43 and a sigma of 0.54.
I think maybe why I was confused is because remember my calculator is different and you have to like put. Could you,
Yeah, you have to adjust it your way, but all I know is the mean is 5.43, sigma's 0.54, negative infinity to 5.05 to 4 decibels should give you 0.2408.
and so when you put infinity, you just put a whole bunch of numbers.
I just do negative 99999.
Okay,
You know, I just tap in a bunch of nines.
and so that's the same for the other one too. Then you just put
Oh,
different
that's same
numbers.
same idea. Yeah. Yeah.
Okay, I obviously got that one wrong because my other answers were wrong. Okay, thank you.
You're welcome.
So you guys can stop looking at my score.
Yeah. I don't even remember that you got like a 68 or something, so don't worry about it. All right, so so listen. Exactly, what score? Right. It's a Z-score, that's what it is. So we will have review sessions. I hope you guys show up. If anybody would like to, if anyone has a question during the week, and she is smart, she's very smart. Anyone who puts their face out there has to be smart. And she's a star apparently. So if anyone wants to jump on a Zoom throughout the week, feel like they have a question, something to clear up, I will try to find time to do so. Tuesday night or Thursday night will be best because I won't be teaching because our classes are not going on, but I'll try to find time. I'm more than willing to do that. Just before you just say, I can't answer it, let me go ask him. Try to do it, look things up. It's only as a last resort, okay? Because I am very busy and as much as I want to help you, finding time is not always going to be easy. But if you really feel like you can benefit, I'm more than happy to jump into a meeting with you. Other than that, I just want to say it's been a wonderful semester. I hope you all learned something. I hope you all had a good time. And you're welcome. And I will see you guys next Saturday for sure.